For years after Chernobyl, scientists believed nature would recover faster than humans. Radiation would fade, forests would regrow, animals would adapt. Time, they thought, would quietly undo what people had done in a single night. It was a comforting idea, one that allowed officials to believe the damage, while severe, was ultimately temporary. They were wrong. What Chernobyl did to nature wasn't just damage. It was disruption at a fundamental level, a slow, invisible rewriting of how living systems behave. And nowhere was that more apparent than in the forest that absorbed the full force of the radioactive fallout. They called it the Red Forest. In the hours after Reactor 4 exploded, a towering plume of radioactive material shot into the sky. It didn't drift evenly across Europe. Weather conditions pushed the heaviest contamination northwest, straight into a dense pine forest just outside the plant. When the particles settled, they didn't simply dust the landscape. They saturated it. The radiation dose was so intense that the pine trees died almost immediately. Their needles turned a deep rust red within days, as if the forest itself had been scorched without flame. To those who saw it firsthand, the sight was unnerving. Entire stretches of forest stood silent and lifeless, their color wrong, their smell unfamiliar. Soviet scientists rushed in to assess the damage, but even they assumed this was a short chapter. Dead trees would fall, new ones would grow. Radiation, they believed, would disperse. That assumption shaped every decision that followed. Instead of treating the forest as a long-term hazard, authorities treated it as a cleanup problem. Bulldozers were brought in. Entire sections of forest were flattened. Contaminated trees were buried in trenches and covered with soil. On paper, it looked like progress. The dead forest disappeared from view. The land looked stable again, but the contamination didn't disappear. It was sealed in. What scientists didn't fully understand at the time was how radiation behaves inside living systems. Pine trees acted like sponges, pulling radioactive particles into their needles, bark, and roots. When they died, those particles didn't leave. They transferred into the soil, concentrating contamination in layers that would persist for decades. Instead of breaking down, the forest became a radioactive reservoir. Years later, researchers returned, expecting to find recovery. Grass, new trees, signs of balance returning. What they found instead was something far stranger. Plant life had returned, but it behaved differently. Some species grew unusually fast, others developed distorted shapes. Growth patterns became uneven, unpredictable. More importantly, decay slowed dramatically. In a normal forest, microorganisms break down fallen leaves, dead trees, and organic matter, recycling nutrients back into the ecosystem. In the Red Forest, radiation damaged those microorganisms. Dead material accumulated instead of decomposing. That detail changed everything. The forest floor thickened with radioactive debris. Fallen branches and leaves remained intact far longer than they should have. Over time, this created a dense fuel layer, unlike anything seen in a healthy ecosystem. It turned the Red Forest into a wildfire risk, with consequences no one had planned for. When fires burn in ordinary forests, the damage is local. When fires burn in the Red Forest, they do something far more dangerous. They re-release radioactive particles trapped in soil and vegetation back into the atmosphere. Smoke becomes contaminated. Ash carries radiation far beyond the exclusion zone. Entire regions can be re-exposed decades after the original disaster. This wasn't theoretical. It happened. Wildfires in and around Chernobyl have repeatedly caused radiation spikes detected hundreds of kilometers away. Each fire essentially reactivates part of the disaster. The forest doesn't just remember Chernobyl, it repeats it. Animals return too, but again, not as expected. At first, the absence of humans created a powerful illusion. Wolves moved in. Deer populations increased. Wild horses roamed freely. Camera footage showed animals thriving, and many observers declared the exclusion zone proof that nature flourishes when people disappear. The truth was more complicated. Closer studies revealed subtle but serious effects. Some animals lived shorter lives. Others showed reproductive abnormalities. Certain species avoided the most contaminated areas altogether, even when food was plentiful. Insects displayed altered population patterns. Bird numbers declined near radiation hotspots, not because of predators, but because radiation interfered with their ability to reproduce and survive. There were no movie-style mutations, no glowing creatures, just quiet biological stress. DNA damage that didn't always kill immediately, but weakened life over time. Immune systems faltered, development slowed, survival became harder in ways that were difficult to measure without long-term study. Plants showed similar patterns. In heavily contaminated zones, biodiversity dropped. Radiation-resistant species began to dominate, pushing out more sensitive plants. The ecosystem simplified itself. It survived, but in a diminished form, less complex, less resilient, more fragile. This challenged a long-held belief among ecologists that nature always heals itself given enough time. Chernobyl suggested something else, that nature adapts, but adaptation isn't the same as recovery. Perhaps the most unsettling discovery came decades later, when scientists noticed radiation levels behaving in ways they hadn't predicted. In some parts of the Red Forest, radiation wasn't declining steadily. In certain hotspots, it was increasing. The reason was movement. Soil erosion, seasonal flooding, animal burrowing, and even tree root systems slowly redistributed buried radioactive material. Contamination that had been sealed underground began creeping back toward the surface. Each disturbance reshuffled the radiation landscape, creating unpredictable pockets of danger. The forest was not stabilizing. It was shifting. This forced researchers to confront an uncomfortable reality. The environment wasn't healing on a human timeline, and it wasn't behaving according to clean models. It was dynamic, unpredictable, and still dangerous. Chernobyl didn't just poison the land, it altered the processes that govern life within it. Today, the Red Forest remains one of the most radioactive natural environments on Earth. Entry is strictly controlled. Scientists monitor radiation levels constantly. Even brief exposure in certain areas can exceed safe limits. And while the forest appears green again from a distance, the danger hasn't faded. Climate change has added a new layer of risk. Hotter summers and drier conditions increase wildfire frequency. Each fire carries the potential to spread radioactive material across large regions. What was once considered a contained disaster is now part of an ongoing environmental challenge. The original belief was that humans would suffer most and nature would endure. Instead, Chernobyl revealed something far more unsettling. That damage doesn't always disappear. Sometimes it embeds itself into living systems, altering them quietly, permanently. Sometimes recovery is not restoration, but transformation. The Red Forest stands as a warning, not dramatic, not loud, just persistent. From above, it looks peaceful now. Trees sway in the wind. Animals move through the undergrowth. Life continues. But beneath the soil, beneath the roots, beneath the calm surface, the consequences of one night in 1986 are still unfolding, and they may be for centuries. E4